So in our previous class we have discussed about the precision full wave rectifier, right? How exactly we can understand the working of the precision full wave rectifier we have seen in detail in the previous class, right, which I took at 9 o'clock today. So moving ahead, we will discuss some other things as long as this signal processing is concerned, that too specifically precision signal processing is concerned. So we will move ahead to the next circuit, that is the clippers. Clipper circuits, rather you can call them as precision clippers also. When I speak about the clippers, probably you have certain background of what clipper circuits are, right? In your analog electronic circuits, you have studied a lot of things related to the clippers as well as the clampers, right? You have the positive clippers, you have the negative clippers. You can make use of the circuits in such a way that you have both positive as well as negative clippings. So all those things we have seen, but again, using a precision clipper serves a different purpose. As I have already told you, whenever the signals below 0.7 volts are required to be processed, then your conventional diode based clipping circuits may not be useful. So you go with the combination of the operational amplifiers as well as the diodes, right? So in this way, here we will have to look into some of the circuits as well, as long as the clipper operation is concerned, right? So first let us begin with the positive clipper, right, wherein certain portion of the input signal, right, above certain value is required to be clipped. So you will, whenever you say that, so now let me say I have got one input signal, something like this, a sinusoidal waveform or a triangular waveform or a square, whatever it is, right? So now I want to clip off this portion on the positive side. So when I want to clip off this portion, I will have an output something like this. This is going to be my output, right? Of course, if it is a positive clipper, the negative side remains intact. However, if you want to clip on the other side also, you can definitely make use of this kind of waveforms which represent both positive as well as the negative clipping, right? So now in order to do such clippings, right, what kind of mechanisms we adopt, or what we will use as long as an operational amplifier and a diode combination is concerned, right? So that's what we are supposed to see here now. Now let us go into the circuit of this clipper, positive clipper, or before that we can have a small note also to clip certain portion of the input signal, right? So we are going to use these clippers, and probably when you discuss about the different circuits here, right, you should always see from the point of view of their applications. Then only you will enjoy these circuits. Otherwise all these circuits will become monotonous, because you have the same op-amp, you have got the same resistances, so you have got the same power supplies, right? So maybe they are arranged here and there, right? But where exactly you find the use of these circuits, right? So that plays a very, very important role for you to understand the basic circuitry concepts, right? So why do you want to clip off some portion of the input? Can anybody tell me? You have already studied these things. Why do you want to clip off certain portion of the input signal? Where do you think that you will use such circuits? Anyone? Am I audible to all of you?
Yes, sir.
Okay.
Yes, sir.
So why do you want to clip off a signal, a certain portion of the signal? Where do you think that you will use them? Now say you have got some randomly varying signal, something goes like this, right? Basically this is one random signal, right? But you don't want this signal to exceed certain value. You want the signal to be having only this much value, right? So that time, see, once this level is obtained, so you will be clipping off this signal. That means always you maintain this value below this. Okay, maybe in some kind of protection you will use it, right? And in communications, right, whenever you want to modulate the signals, right, so basically the clampers are used for that purpose. You add some DC and remove it at the end. Anyway, we will discuss about that later. But this clipping configurations also can be used, right? So you, if you know precisely where exactly you have clipped, so at the end you can reproduce it, right? If at all you want to send some encrypted information, analog information, right, so that it goes in an anonymous way from one side to another side, and at the end you should be able to retrieve the signal. In such cases these kind of circuits are used, right? So if you feel that certain portion of input signal which is analog, right, if it is unnecessary, right, so then you can definitely clip this thing off and you can retain whatever the useful portion of the signal, right, continuously varying signal. For all these reasons your clipper circuits are used. So now let us try to look into the circuit of this clipper. So I have the operational amplifier as usual. Okay, so now I give the input here, of course, to the inverting terminal, and look here, the non-inverting terminal, sorry, I give the input to the non-inverting terminal and I connect a diode here in the feedback path. These kind of things you have already seen earlier. Now here I make use of a resistance, something like this. Then I connect it to the load. So this is my V in, power supply, this is the diode, and let me say that this I will call as RL, and this is my V reference. All of you please have the circuit here. This is my output voltage. Here of course we will take the values in the form of certain levels so that we can easily understand these things. This is T, V in. Let us say I have, one second, yeah, I have V in equal to 2 volts, and V reference equal to 1 volt. It is easy for me to have the analysis. Yeah, this is what is going to be my output. All of you please draw it. This looks sensible. All of you are able to draw these things. Are you drawing?
Yes, sir.
Okay, okay.
Yes, sir.
These things are clearly visible, right?
Yes, sir.
Okay. This is one configuration. Please try to understand these things clearly, so that if you understand the basic principle behind it, so you should be able to draw any configuration you want, right? So sometimes you may be given the waveforms, so from which you should be able to draw the circuit as well. Okay. So now if I assume that you have drawn it, right? So VCC I have taken. Generally both these VCCs are taken from the same supply in order to avoid using one more power supply, right? So in many of the books, this is directly connected here. Okay, you can, this VCC, okay, whatever I have drawn here, this is directly connected here. And you will now basically what is this circuit basically? Can anybody tell me? It is a circuit with it is
Series
basically, yeah, yes,
series clipper.
no, series clipper is the application. It is basically a voltage follower with diode in feedback path, correct or not? Correct or not here? So you are giving the input. That is the reason why I had been telling you to understand the working of the first three configurations very clearly: voltage follower, inverting amplifier, non-inverting amplifier. Now if you don't consider this part, the output part, you have V in, you have diode, and you have got a feedback here, right? So only these three. So are you able to see the movement of the cursor in your screen?
Yes, sir.
you
Yes,
can
sir.
you can see the movement of the cursor, right? So you should understand then. So now if I don't consider this part, okay, the other part, so only this portion is the voltage follower with a diode in the feedback path. Am I right? Yeah. So now next, actually here V reference, okay, it decides the clipping level. V reference decides the clipping level. So this is another important point to be noted here, right? Now one more important thing what you should take here is, that is the condition rather, right? So your V reference should always be less than V in for proper working. for proper working of the circuit. Yeah. Okay, fine. So if your V reference itself is more than V in, then it doesn't make any sense to draw this circuit, right? I hope you can understand what I have been telling there, right? Right. So now let us try to look into the working of it. Working of the clippers or clipping circuits, and please remember, it is only one small part of the different clipping configurations that you can have, right? But if you understand this, so probably you should be able to understand all other circuits also, right? So now working, every time when I start explaining the working, you should always start from this particular point, okay, when during the positive half cycle, or when your V in is greater than 0, right? So that is what is the starting point during the positive half cycle. During the positive half cycle, so what happens during the positive half cycle? Now you should be able to parallelly tell the things, right? So during the positive half cycle, what happens? The diode will be able to conduct only till your V in is equals to V reference. Am I right or not? During the positive half cycle, the diode will be able to conduct only till your V in is equals to V reference, right? It will increase like this, right? It will increase like that. This feedback path, this is also going to be closed, and your diode will be able to conduct, right? During the positive half cycle, diode D conducts till V in is equals to V reference. During the positive half cycle, the diode conducts till V in is equals to V reference, right? So now when V in is greater than V reference, what happens? When V in is greater than V reference, see, V reference is this voltage, please try to understand, okay, the reference voltage. Now the reference voltage here, okay, please check what happens when V in is, okay, first let us take the case of V in less than V reference. One second. When V in is less than V reference, we will start with this particular condition, right? V reference at inverting terminal. So inverting terminal is this inverting terminal, okay, it will be definitely greater than, is greater than V in at non inverting terminal. I am writing all these things so that you can parallelly note down these things, so that you will not have the problems of the notes and other things, right? So when V reference is less, or when V in is less than your V reference, right? So definitely the voltage at the inverting terminal, okay, this terminal is greater than that of the voltage at the non-inverting terminal. So what happens when it is so? Let me write this voltage as V naught dash here. We'll write this as V naught dash for our understanding, okay. So now, okay, now you can see. So definitely your V naught dash, it becomes negative. the output voltage V naught dash becomes negative, right? So once V naught dash becomes negative, it will make the diode D forward biased, the feedback path is closed. This is the condition when your V in is less than V reference, right? You please look at this circuit. So that is, I am talking about the condition till this point, till this particular point. I hope all of you are understanding, right? So say your V in is 0.5 volts or 0.6 volts or something like that. So that time definitely your V naught dash is negative. When this is negative, your diode is conducting, right? So one second, V naught dash, I have to take it here. Wrongly I have written, nobody has noticed it. This, if I write V naught dash, does it make any sense? Because both are same, right? I have to write V naught dash here. Nobody has informed. Correct or not, students? My V naught dash is here. I had wrongly written it as here, right? So then V naught and V naught dash would not have made any difference, right? So when V naught dash is negative, the diode is reverse biased. This analysis we have already seen earlier. So obviously this path is closed, right? So when this path is closed, right? So what happens? Your output V naught follows the input V in till where? Till your V in is equals to V reference. Your output V naught will follow V in till your V in is equals to V reference. This is one part of the working, and basically it is working as a voltage follower, right? So now the remaining part probably you should be able to write on your own, because I have considered the case of when V in is less than V reference. Now when V in is greater than V reference, this is the second case. When V in is less than V reference, when V in is greater than V reference. So what happens? Your V naught dash obviously becomes positive. Am I right? V naught dash becomes positive, and your diode is reverse biased. The diode is reverse biased, and this will make the feedback path to open. The feedback path is going to get open, right? So this will keep your output V naught at V reference. V naught is kept at V reference only. Your V naught is kept as at V reference only, or V naught is equals to V reference. Why it is so? Because your V naught swings towards plus VCC, right? So V naught dash is approximate, because it has to switch between plus VCC and minus VEE. So your V naught dash is now approximately at plus VCC. So therefore your output V naught will be held at V reference only, right? So now this is the second case. Next, suppose if you want to consider the further case here, right? So let me draw the things now. Next, when your V in drops below V reference. So up to here we have come now. Okay, now here, this up to here it will be all right. Now when we go in the negative direction, when V in drops below V reference, obviously your V naught dash now will be again negative. V naught dash will be negative, this voltage will be negative. So your D1 is, or your diode D, it is not D1, it is forward biased, it is driven into conduction, it is driven into conduction. Again your feedback path is closed, feedback path is closed, and your output follows the input, the output follows the input. So you would continue to go like this till you come to this particular point, and again the same thing happens here onwards. So basically here your diode D, okay, this plays the entire role. It is on for V in less than V reference, it is the summary, and it is off for V in greater than V reference. All of you are following it or not? The diode is on for V in less than V reference and off for V in greater than V reference, right? So when your diode is on, your output simply follows the input. When the diode is on, your output simply follows the input, and you will have this kind of output waveform, that is the positive part is going to get clipped, right? So this operational amplifier also alternates between the open loop and closed loop. The op-amp alternates between open loop and closed loop. Op-amp alternates between the open loop and closed loop. That is the reason why your operational amplifiers which we are going to use here cannot be your IC741 and all. They should be high speed operational amplifier, because the input frequency also matters. It should keep switching between the open loop and closed loop at the rate of the input signal, which is decided by the input frequency. So therefore generally the low speed operational amplifiers cannot be used here. Same the explanation holds good even for your diode also. We have already seen the reverse recovery time as well as the peak inverse voltage. Okay, so all of you have understood this or not? The positive clipper circuit. Positive clipper circuit. Now can anybody tell me, if I want to convert it into a negative clipper circuit, what changes I have to make? If I want to convert it into a negative clipper circuit, what changes I have to make? Am I audible to all of you?
Diode, sir.
Yes, sir.
Yeah.
Yes, sir.
Diode.
Reversing the
Diode
diode.
direction should be changed, sir.
If you change the direction of the diode alone, do you think that you would get a waveform of this kind?
We should be negative terminal.
Yes, very good. Can you repeat that?
We should be able to negative terminal.
I'm not able to listen to you clearly. This VCC, whatever you are having here, right? It should be minus VEE, or it should be a negative voltage, correct or not, right? So then only whatever the conditions we have taken here, all these conditions hold good, right? So if you simply reverse the diode, okay, here by keeping this as VCC, so what you expect here, if you simply see, both the conditions should hold good. The diode should be reversed and your reference voltage should be minus. Okay, the reference voltage should be negative here. Then only you will get the other way around. Suppose if you keep the voltage as positive only, and if you simply reverse the diode, or if you keep the diode as it is now, right? So with this whatever, and if you simply reverse the voltage, what will happen? If you now, let us take the case of simply reversing the voltage here, right? So let me just go to the next slide, wherein I will keep the diode as it is. Okay, okay, this is minus VCC. I will take again the pot. This is my reference voltage. Let us take this as V reference RL. This, let me take this as pot RP. So this is the diode and this is what is the input, right? So input is given to non-inverting terminal and this is connected like this, right? So now in this circuit, as compared to the previous circuit, what changes I have made is, instead of plus VCC, I have connected it to minus CC. So what you expect here? Can you draw the waveform? Please draw the waveform at output. You can try this. You just have the analysis of the circuit, right? You just try this. So you will have the input something like this. This is T, this is V in, right? You just draw the output. What will be the output here? This is going to be your V0. It's V0. So this is your V0 dash. Okay. So this can be taken as an exercise. Now, if you, one second. Yeah, I don't know, where did I miss it? Yeah. Suppose if you draw the circuit like this, this is plus, this is minus. Please check the direction of the diode here now, as well as minus VCC. This is V0. This is my V reference. This is the diode. This is my V in. If this is the case, so the analysis what we have made for our previous positive clipper, the same analysis holds good to get the output of a negative clipper, something like this. Let us draw the things very clearly so that let there not be any confusion. Yeah. Now you can see here, if you take this as 2 volts, this will remain as 2 volts, and here you will have minus 1 volt. So this will be minus 2 volt. So this is going to be your output if the diode is reversed, right? So probably you can understand how you can get it. So diode conducts when your input voltage is greater than, so that is your D is on when V in is greater than minus V reference. This will be minus V reference, right? So your V naught follows input or your V in. D is off when D is off when your V in is less than minus V reference, right? So loop opens. The same explanation what we have taken previously holds good here also. This is one school of thought to get the clippers, right? Now if you reverse the diode here in this case, right, previously what we have taken for that, or even this circuit we have already taken, and even in this circuit, right, if you put the diode in the other direction, what would have happened? Please try to analyze. Of course the explanation and other things are very well given in the books also. Okay, so this is one thing. And now let me draw one more circuit here. Please try to understand in what way this circuit can work, right? And please try to understand the difference also between what we have drawn so far and what I am going to draw now. So again I have got one operational amplifier here. Now you see here, you should be immediately in a position to understand what circuit I have drawn here. Quickly, somebody, if you want, you can put one resistance also here. Minus, plus. Which is this circuit? Fast. When
Inverting amplifier.
yeah, when you don't answer, I feel that my connection is lost, right? At least tell something. If you don't know, we don't know, like that, at least you tell, okay? Because I am not able to see you. That is the biggest problem here. It is an inverting amplifier, simple inverting amplifier. If you want, you can take R3 also here, right? We have designed these things. Now in this circuit, please try to see what I will do here is I will add a, what is this?
Zener diode. Zener diode.
Yes. Let me call this as Z1 and Z2. Okay. So this Z1 and Z2 are, let us say that they are having the cutoff voltage of 5 volts. And let me say my input signal is this. This is my V in. Let us say that it is 10 volts. This is an example. Okay, you can have anything you want there. Now the presence of this Zener diode, in what way it will change the working of this inverting amplifier? I have connected the two Zener diodes in opposite directions, is it not? Now Can somebody analyze this? Can somebody tell what exactly happens? What will be your output here? I draw the output with a dotted line so that we can complete it. If somebody has unmuted, good, but you should answer. Oh, stopped. Yes? So now this you should be able to tell me quickly, because you know the working of the Zener diodes and all, right? What for the Zener diodes are used? Zener, analog electronics. Nobody?
Voltage regulators.
Yeah, they are used as a voltage regulator. Fine. What do you mean by voltage regulator? What do you understand by voltage regulator? It will keep the voltage at a constant level. Am I right? That's what is your Zener breakdown volt here, right? So you have, let us say that 5, it will not allow the voltage across it to go above 5 volts. Am I right or not?
Yes, sir.
Okay. So now I have got an input voltage of 10 volts. So now see here, this is the simple working of your inverting amplifier. As okay, of course I have to take the output here in the, one second, since it is an inverting amplifier I have to invert it. I cannot take it as it is, correct or not? So I will take it something like this. It's an inverting amplifier. Am I right? So let us take from this particular point. So when it is going in the positive direction, now when the voltage reaches 5 volts, it is my 10 volts, voltage reaches 5 volt, right? So the voltage across this RF will be clamped to 5 volts. Am I right? Voltage across RF means what? It is the output voltage. So I have to take V0, that is clamped at 5 voltage, 5 volts, something like this, right? So because I have used the two Zeners in the opposite direction, the same thing would happen even in the first half cycle, which is the positive half cycle. Will I not get this kind of waveform? It will never allow the output voltage to cross 5 volt. Very strictly speaking, it is 5 plus 0.7 volts. Can somebody tell me why it is 5.7 volts? From your understandings, previous understandings. Whatever the Zener diode is in the forward bias condition, the voltage across it will be 0.7 volts, assuming that the 0.7 volt is the on state drop of your Zener diode, right? So to this, the reverse voltage of the other Zener, which is in the opposite direction, that gets added, right? So that is the reason why you are going to have plus or minus 5.7 volts here, right? In all our previous analysis also, we have ignored deliberately, because see, when I say the diode has come into picture, the voltage drop across the diode, whatever it is 0.7 volt or something like that, right? So that should be considered. But in this particular case, previous case, the voltage across the diode gets divided by the factor of the open loop gain. That is the reason why we have not considered. But in this case, strictly speaking, in all the cases, whenever you consider the total voltage, the drop across the diode also needs to be considered, right? So that is the actual thing. But here in this case, since we have not used the other diodes and it is not being used in the precision rectification, because I have used 10 volts here, 5.7 volts, basically it is a conventional clipping circuit only using the operational amplifier. So the total voltage to which both the input positive half cycle and negative half cycle gets clipped will be 5.7 volts. So this is one very important thing as long as using the Zener diode is concerned, right? So now if you draw the the input output characteristics V in and V out, you would get something like this. The characteristics, correct or not? So this is your RF by R1 slope, okay, and here this voltage, this is minus Vz plus 0.7, so minus Vz plus 0.7, and here this is plus Vz minus 0.7, right? Please check whether this is correct or not, because that depends upon the, yeah, so this is Vz, yeah, correct, it is not 5.7, it will be 4.3. Please check, minus Vz plus 0.7 plus Vz minus 0.7. Please check this, right, these values, whatever I have written here, right? So this, the drop across one Zener, that is also going to be considered while considering the total clamping voltage. So this is also a kind of the clippers, right, wherein we are not using the diode here, but we are using the Zener diode. Instead of the diodes, we are using the Zener diode, right? So you can take certain examples. I think I had given you one question in our question bank, the question on the adjustable clippers, right? So adjustable clippers means what? So you have something like this. So this is the waveform. So you should be able to adjust the output between two values. So this is one, okay, the other would be something like this. Other would be something like this. So let us say that this is 2 volts and this is 4 volt. On both the sides you should be able to have that. Now you can just think of how it is possible for us to adjust the output voltage like this. So this will be, say, minus 2 volts and this will be minus 4 volts. So this is what is your expected output waveform, right? So the adjustable clippers. So to one value, it is always uneconomical to clip the value. You should be able to adjust the pot in such a way that you have the different reference voltage values. So here if I come back, whatever the reference value you are having, I will go back to the first slide. Yeah, so this reference voltage, if you are able to adjust this reference voltage here, as long as it is a positive clipper, so you will be able to have the the output voltage also clipped between two voltage levels, say 1 volt and 2 volt or 1.5 volt and 2 volts. That is all decided by what value of VCC you are using and what value of the reference voltage you are going to get here, right? So as long as it is the other way around, that is the negative clipper, then also you will be adjusting the value of V reference here. But if you want to have it on both the sides, right, like what we have seen here, then probably you must use the Zener diodes, and here you should devise a mechanism to adjust the output voltage between two clipped values, between this value and this value, or between this value and this value. That's how you should be able to solve certain examples here. Let us see these things later.